Thank you, everybody. Thank you to the organizers for inviting me to this great conference. And thank you to be here and share the next hour with me. I am Marco Consolaro. I am a software crafter. I work in software development for more than 20 years. And recently, I decided to move into training. So I co-founded Alcor Academy with my friend Alessandro Di Gioia, sitting down there. But the best achievement so far was writing Agile Technical Practices Distilled, a book about technical practices, how to learn all the cool technical things about Agile development, together with my friend Pedro Santos as well. So today we talk about connaissance, right, beyond coupling and cohesion. And I really like the quote from Van Gogh, right? Great things are done by a series of small things brought together, because it's a little bit the picture about connaissance. Now the thing is, in our code, we couple things together in many ways, and there are good ways and bad ways we can couple things together, and the problem is that we don't really think about that. So some nasty way of coupling things get into our code, and that makes things very difficult in the long run. So let's see a little bit where this idea of connaissance started. It was 1995, and in this book of Mailer Page Jones, there was a chapter about connaissance, the first time that this concept came out. And to me, I started to learn about connaissance when I was working with my friend Pedro Santos. He asked me, have you ever seen this idea? And for me, that was really new. It was a few years ago. And so when I saw it from Pedro, I was really, really interested. It was something really cool. So I went online and I found the videos from Jim Weirich, which actually claimed connaissance to be the grand unified theory of software design. And maybe it's a little bit pretentious, right? Maybe it's not as big. However, it's an idea that is very, very interesting. And the problem I had with the talk of Jimmy was that he was a Ruby developer, very, very famous Ruby developer. If you ever use a rake build written in Ruby, it was written by Jimmy. And the example in Ruby were a little bit hard for me to understand. I come from .NET Java world, so that was what made me think maybe I should do my version of this talk with some example in a more clear language. But however, if you're interested in the subject, I suggest you to look at this video. Now, unfortunately, he passed away. I had a lot of questions to ask him, and I realized that he passed away a few years ago, so I couldn't ask him anything. So, connaissance, what is the concept of connaissance? It comes from Latin. It's from co and nascence. Now here we speak French, so we should be a little bit more familiar than UK about Latin. And it means, nascence means nascentem, so to be born, right? And co means together. So connaissance is the birth and growth of two or more things at the same time, right? So from this point of view, the definition of connaissance is very, very similar of the definition of coupling. As far as Kent Beck say, oh, connaissance is the same of coupling, I already know coupling, and I'm not interested to know more about connaissance, it's a double in my concept. Why I believe that there are a few ideas of connaissance that are unique to it, and we will see later with some example that some situation, it's really hard to talk about something if we don't have the ideas of connaissance. So two or more elements, field, method, classes, parameter are connaissance. If a change in one element will require also a change in the other. And here it's clear, right? But it has a taxonomy in 3 dimensions. It's not just about the fact that they are connected. The fact is that we can connect many things, right? So there is a degree in the impact because we can connect one thing or we can connect many things at the same time. So the degree of the impact, it matters, right? Then we have the locality, the distance between the two things we are coupling together matters as well. Are they close together in the logical hierarchy of our abstraction, or are they far away? Because if they are close, it's quite good. If they are far away, it's pretty hard to understand why they had to be coupled. And then the strength. Here the idea is that there are a lot of things that we might couple without us to realize it. And that is connected with the strength of this couple. The more abstract is the thing we couple together, the more strength, the more difficult it is to clean it up and come out with a good design. So essentially, it gives us a well-defined path about refactoring. If we have a high degree, we want to reduce it. If we couple things far away, we want to bring them together. And if we introduce strong form of connaissance, we want to try to come with the weak and good forms of connaissance. I know what you are thinking, right? Show me some code. Otherwise, we are talking about Friday. How many developers in the room? Okay, very good. A lot of developers, really happy. So you will love this presentation because now we start with some code, right? So let's see this class, right? Apparently innocent class. It's a class that we instantiate with the time, and then it has a method to display the time we instantiate, right? So here we see how connaissance works. So, for example, we give this name to the hour field here, right? So here, if we change any one of these 3 appearances of this field, we have to change also the order. So these 3 appearances are connaissant. And the same is for minutes and seconds. And the same is for the name of our parameter and the assignment inside the method. This is called connaissance of name. And another one, very, very good kind of connaissance, right? This type. If I change the type of the first field, we have to change the type also of the parameter, otherwise it doesn't work. Same for this one, and same for this one. This is called connaissance of type. These are the good kind of connaissance, right? That's all we should use in our code. And now you might think, well, that's the basics of software development. Of course, we just use this kind of connaissance, right? But I will show you how many other kind of connaissance we have that can always, or must always, be reduced in these 2. And these are static form of connaissance. These are form of connaissance that we can resolve at compile time. That's why we have the compiler that tells us if we break this kind of connaissance, the compiler says, hey, I can't work. Connaissance of name type is broken. You need to fix it. And this is good. It makes our life easy because we have a compile time proof about the correctness of this. And this is also why languages like JavaScript or not strongly typed are more difficult to handle because the connaissance of type will be moving up in this ladder because it becomes dynamic and not static. And that's why it makes the things more difficult. So let's see a different interesting form of connaissance. Let's see this example. We have a notificator class that sends email, right? And it receives in input 3 strings. One is the recipient, one is the sender, and the other one is the message, right? So here, then when we use it is send email, one email address, then another email address, then another text. And here, when I have to use classes like this, I'm always like, wait a second, is the first email the destination, or is the first email the sender? I need to have the prompt from the IDE to see the name of the parameter to remember what is what. So this is kind of risky, right? And so here, the idea is that what we are doing, we are coupling the position of our parameters with the meaning of that, right? So the first one is the recipient, the second one is the sender, and the third one is the message. And this is called connaissance of position. Connaissance of position happens when multiple components must be adjacent or must appear in a particular order, sometimes also passed inside an array, for example, where if you pass an array where the first parameter do one thing, the second is another one, the other one is another one, well, that is still connaissance of position. So how strong is it? It is quite strong, right? It's the strongest form of static connaissance. The thing is that it's easily solved, right? Because as far as we create a type that represents a recipient, a sender, and the message, at this point, we are not linked to a position anymore. We have a type that explains what that is. So we transform connaissance of position in connaissance of name and type. An alternative is to use a fluent interface, right? We create a notification class, and then we use method to set up everything else. It's still connaissance of name and type, and we solve connaissance of position. Let's see another example, right? This is a strongest one, the stronger one. This is a very bad one, and we can find it very often. So what happens if we instantiate our time class in this way, right? Hour 27, not a real hour. Minute 76, and second 82, right? This is not a valid time, right? And we are introducing invalid state. This is also called connaissance of value. Connaissance of value happens when two or more components' value are related or have an intrinsic range of validity in their input, not expressed by their primitive types. So here, the idea is that, and how strong is it? It's very strong. See, it's one of the strongest forms of connaissance. Here, the idea is that the class should participate in the information flow if and only if its state is valid. So, as a bare minimum, we need to validate the input as soon as we try to create this class. A better way is to actually create the sets of valid input and essentially not even allow this class to be created with a value different from the one that it can accept. And here, essentially, we use the type system to make invalid state unrepresentable. This class don't need to be validated anymore. It's just impossible to instantiate it wrongly. And also here, we use connaissance of name and type in order to achieve this. Let's see another one. This is very common in web forms. It was very common once upon a time. Let's suppose we have a web page that for a survey about how the people go in the office in the morning, all right? And so there is a web page with a checkbox, and if it's a bike, the value is 1. If it is 2, it's car. If it is 3, it's train. And 4 is bus, right? And so the controller has to replicate the same check in order to understand the answer, right? And this is called connaissance of meaning, right? Connaissance of meaning or convention happens when two or more components must agree on the meaning of a specific value, hence introducing a convention, right? This is not very strong, right? But the thing is that it's very, very easy to clean, right? It's very easy to just don't introduce it, right? We can just declare a constant that explains the value, right? Constant is bike is 1, car is 2, train is 3, and bus is 4. And now every other component just use the constant without relying on arbitrary value. So also here, we reduce it to connaissance of name and type. So let's see another example. This is about code repetition, right? So let's suppose we have a checksum algorithm which adds the last number in order to divide the number by 10, right? So the first one is true, and the second is false. And so this is the code that implemented. There is an add checksum method and a check, right? So here the problem is that we introduce some code repetition in these two methods. Essentially, we calculate the algorithm in the same way 2 different times. And this is code. It's also divergent change codesmap, right? Because if we change in one side, we need to change also in the other side. It's called connaissance of algorithm. So connaissance of algorithm happens when 2 or more components must agree on using a particular algorithm, right? Essentially when there is some code repetition. This is the last of the static form of connaissance. And also here, it's pretty easy to clean, right? We just have to extract the right method in order to reuse it every time we need to call this algorithm, run this algorithm. And it is called connaissance of, we go back to connaissance of name and type, right? So let's move to some more exciting form of connaissance, right? Some kind of connaissance we put there, and we don't really understand that it's bad many times. So, for example, let's see this piece of code. It's a code that sends receipts, right? But it has a problem. No? First, it sends the receipt, and then it archives the receipt, right? But the problem of this class is that if we invert these two calls, the receipt sender, right? If we first archive and then send the receipt, it throws an exception. So we need to know that we need to call the send to customer method before calling the archive method. And this is called connaissance of execution order. Connaissance of execution order happens when the caller of a component must have some prior unexpressed knowledge about the correct order of the methods to be called, right? It's like we give an interface to use to the developer that code to our class with a very well-defined order about how to call the methods, but we are not there to explain it, right? When the developer sees the class, it just tries to call the methods, but there's nothing that tells him what is the right order. And that is a problem, because this is some knowledge that is not expressed in our code. And that makes it very, very difficult for the poor developer to guess the right order if no one tells him, right? That's why it is a problem. And this is a strong form of connaissance. It's dynamic. And we can discover only in runtime. The compiler don't know. It's just a method. But if at runtime we unfortunately use the different order, well, in that point, the system is going to blow. And it's very, very bad. So let's see an example, right? Let's see a builder pattern, right? A very, very famous pattern, right? And the builder pattern is an example of the use of connaissance of execution order. Because how do we use this pattern? First, we set up the builder, right? And then we call the final method build, that build the concrete. And this is a form of connaissance of execution order expressed by convention, right? Well, we know how the pattern works, we know how it has to be used, and so by convention, we know how is the order of the methods. But here the challenge is, can we make it better? Can we make a builder pattern where we can enforce the order of the methods without let the user guess how it has to be used? Well, let's see. Let's try to segregate the interface, right? So we can create an interface that say, I build cars with brand, and then return a different interface, which is I build cars with engine. And then it returns a different interface, that is I build car with color. And that return the interface of the builder that actually has the method to return the concrete. So the builders will inherit all these interfaces, right? And then we can enforce the start interface through a factory method. And here we go. When we use it, we can now do this new. And then we have the interface that is just, oh, tell me the brand. And then we have the other one, tell me the NG. And then the color, and then build. Here we have only connaissance of name and type, and no more connaissance of execution order. Now, it's impossible to use this builder differently than just with the path we have defined. So let's see another kind of connaissance. So developers here, what's weird here? Anyone? There is a line of code here that's not that good. It's every time I see this, every time I do this, I feel a little bit bad. Slip, right? Somebody say, thread slip, right? What is this, right? This is connaissance of timing. Now, when you do this, it feels bad, but there is not a name for this. Instead, it is connaissance of timing. Connaissance of timing happens when the success of two or more calls depends on the time of when they occur, right? And this is really bad because we are not in control of time. So time is a very, very difficult thing. So how can we overcome this? Well, this is actually very strong form of connaissance, and it's difficult sometimes to handle the time. The problem with time is that sometimes it is a business requirement. Right? Maybe, let's say, we need to send a reminder after 1 week. Right? That is connaissance of timing in the business rules. So we need to map it, and there's nothing we can do. The problem is that in our code, we cannot make a test that wait a week and check if the notification has been sent, right? We don't have a week time to test that stuff. So how can we do? Well, we need to abstract the idea of time in our application. Now here, there is not a receipt for every time that we have this problem. But the idea is that we really need to try to detach ourselves from the idea of time. For example, in this piece of code, this is a code that comes from a real job that I was doing years ago, right? So the way I mitigate this problem was to have an event in the handler that fire every time that a message was received, right? So here the problem is that they couple themselves to the infrastructure of sending messages, and that waiting time was just waiting for the message to arrive. So at this point, I could detach from this. So instead of waiting an arbitrary number of time, I could just wait for the event raised by the handler so that I knew that the message arrived and I can carry on with my test. So here, in all the happy paths, we solved the connaissance of timing. But the thing is that in the unhappy path, we couldn't really get rid of this. But the good thing was that 90% of the tests were about the happy path. So for 90% of the tests, we improved the speed of our test rate of a lot of time. But in the unhappy path, of course, we had to wait that second. However, we improve it of a few minutes, right? And then there are other ways to go around connaissance of timing. For example, another very good way to go around it is to parameterize the time, so that we can make the test about timing in our system run with milliseconds, right? If the system has to wait for 3 minutes before doing something, we can parameterize those 3 minutes. In our test, we can say 300 milliseconds, and have the test to check with the order of magnitude of milliseconds instead of minute. And then in the live system, that is a configuration parameter that becomes 3 minutes. But we don't care in our test, because if it works with milliseconds, it works also with minutes. But the effect is that our test gets super fast if we parameterize the time in a smart way. So let's see another kind of connaissance, which is fortunately not as popular as once upon a time. Now we have distributed computing. And this is why they call singleton an anti-pattern back in the days. Now, this controller is going to work if and only if the global counter is the same instance, right? So this is called connaissance of identity, right? Connaissance of identity happens when one or more components must reference exactly one particular instance of another entity to work. And this one is the strongest form of connaissance for Mailer-Page Jones. But in our life, we found that there was also another kind of connaissance, probably worse than all the one I mentioned so far. So I was working in the team of the code of before, where there were connaissances of timing. And essentially, I refactor all the infrastructure to handle the messages, and we had to add new messages. We had to emit 2 new messages in that team for other bounded context to do some stuff with that. And so I took the occasion to refactor this thing, improve the test, improve the thing. And so we put the new messages, and my machine was working perfectly. We were pairing on my machine, everything was perfect. The team lead that was there since a long time was really happy. And so at the moment, we push to the continuous integration. And so it goes in continuous integration, break the pipeline. And so what happened? And so we start to investigate. And for me, it was impossible to understand what happened, because to me, everything was fine, right? And so we spent all the day investigate until the team lead had the epiphany. It was like, now I remember. I remember what, right? Now I remember that every time we add a new message type, we have to go in the building script and tell the building script that there is a new message type. I was like, you are crazy. So you understand the problem there. They couple the code base to a manual task to do somewhere in the script that was only in the mind of the oldest member of the team, which he forgot. We will be still there, try to understand why it didn't work, right? And so for us, this was a new connaissance type, right? And we call it connaissance of manual task. Connaissance of manual task happened when expanding the functionality of the code base required some manual tests to be executed outside the code base. Right? So basically impossible to know. That's if you want to give trouble to a team, let's put a lot of connaissance of manual task. Right? So for us, this is the strongest part of dynamic connaissance. In fact, in our book, we say add enough manual tasks and team will spend more time trying to make things work, fidgeting with scripts and configuration, instead than focusing on writing well-designed code. So let's close. Right? We have seen all the kind of connaissance. As my friend Pedro Santos says, it's all about design. Right? So I love this quote from Claude Shannon. We know the past, but cannot control it. We control the future, but cannot know it. The thing is that in software development, that is not necessarily true, because we can change the past. It's called refactoring, right? The thing is that it happens only if we can do it. And that's why the design is really important. Design is really important because it allows us to continuously do meaningful refactoring. And that is something that over time allows us to be faster and faster and faster. The problem if you don't have a good design is that in the beginning you think you are going faster because you don't care about the design. So when you have a small code base, it's easy to fit in your mind. And so you can go faster. The problem is that it gets bigger and bigger and bigger and more coupled and more coupled. And it's more difficult to do refactoring. And so then if you want to refactor it, it takes a long time to refactor it. And the effect of that refactoring, if you see the orange line, is less powerful than the effect of the normal refactoring. And so it gets slower and slower and slower. And so arrive the point where you get slower than who has a good design, and until you have a big ball of mud, you can't touch it anymore. While who have a good design in the beginning go slow, because they are thinking about their design. They are not just pushing things out. They are trying to move things around in order to have a breakthrough for their model and have an effective code base so that they can go faster in the future. And so they keep refactoring, think they get the good breakthrough and actually improve their speed with time. And at that point, when you have teams like this, it seems quite amazing. It happens to me sometimes. We were able to do things in this way in company where they work waterfall. They thought we were alien. And here the idea is that all our tools of software design, however, converge to the same problem. So it doesn't matter if we use coupling or cohesion or connaissance, code smells, solid principle. All these things are gauges for the same thing. Everything is connected in the world of software design. For example, let's see this class, right? This class has long parameter list. It has connaissance of position. It generates the order ID, so it has not single responsibility, right? It passes a lot of parameters, data coupling, primitive obsession, and data clumps, right? But then let's solve connaissance of position, right? We have the customer ID, category ID, that's all things about the order. So why do the order there? Let's extract the order class and pass the order and let this class to do things in the order using connaissance of name and type. Like magic, we solve all the problems in one go. So it's not about which kind of tool we use to analyze and correct our code. It's about to care about that and don't let bad things carry on with time, right? Yeah, the idea is that coupling, cohesion, connaissance, and other things, they all influence themselves, because here the idea is that we are simply trying to tame the entropy of our system. If we remember, one of the definitions of entropy is entropy as the degree of disorder in a system. The more the disorder, the more hard to understand, the more hard to act on our code, the more difficult to maintain and to add new things. So As Alan Kay said, you know who is Alan Kay? I see somebody that came in our workshop yesterday, so somebody for sure know who is Alan Kay. Right? Alan Kay once said, you can write COBOL in any language. And people do that all the time. So please, 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 don't be that people. Okay, we can help, right? For DevOpsDays Geneva, we have a 50% discount of our digital book on LeanPub. And I actually have also a physical copy, self-printed. This is our private version. The other paper version is from Pact, but unfortunately we can't do discount of that because you know, unfortunately we sold our soul to the big guys and they are gone. But this copy is gonna be in the final prize extraction. Oh, thank you. But if you want to really take it to the next level, we are doing training. We train professional team about software design and more programming, and we have to promote a culture of excellence with our innovative socio-technical training, fully remote, fully interactive, and super fun. That's my contacts, and that's all, folks. Thank you.